Welcome back for the second piece of 8-1. So the second piece should actually be pretty simple if you understand the two basics we talked about yesterday. Those two basics being that if you're varying directly, x is going to multiply with a k, and varying inversely means it goes underneath. It is dividing the k. As long as you know those two things, you're going to be awesome at today. Because today we're diving into combination variations. So for combination variations, the first thing you want to do is set up whatever structure that it's talking about. So what does that mean? Well, z varies, so z equals directly with x. So what that means is x is going with the k, and inversely with y. Remember, inversely means it goes on the bottom. All right, so again, exactly like what we talked about yesterday. Now we have a combination of things happening though, okay? We have x varying and y varying with z. Now, just like with yesterday also, this isn't the end because we need to actually have that value for k. We need to know what it is. So I'm going to plug in all of these values. X is 4, y is 6, z is 2. So z is 2 when x is 4 and y is 6. All right, so multiply the 6 over, so we get 12 equals 4k. Divide by the 4, we get that k is 3. So the actual equation that we're looking for, you actually want to put that 3 in for the k. Your final equation should never have k in it. You should always be looking for what k is, using the information provided to you to find k. All right, so again, that's all today really is, just combining all those skills we've already been doing. Now, let's look at this one. Z varies jointly with x and y. Well, that's a new vocabulary term, but here, if you look at my little note for you, all jointly means is that it varies directly with both, okay? It's just a fancy term for that. So if it's varying directly with both, it means both x and y are up with that k, okay, or multiplying k. Well, now we need to find what k is, so let's plug in all of this. So z is 60 when x is 3 and y is 5. So essentially, we get this equation. 60 equals 15k. All I did was multiplied the 3 and the 5 together. Now I want k, so I divide by 15, and I get that my k is 4. And again, you always want to actually write out your equation without k in it. You always end up wanting to plug in that number for k. Right, now this one has even another variable introduced into it. So z varies jointly with x and y. So that means x and y are up with a k. Inversely with w. Again, anything that is inversely goes on the bottom. So once I have that set up, now I can start plugging into all of those values it's talking about so I can actually find what k is. So z is 16, x is 4, y is 2, w is 5. So I'm going to multiply that 5 over. So I have 80 over here. And then the 4 times the 2 is just 8. Divide by the 8. I get that my k is going to be 10. So what do I do now? Well, I need to actually put that 10 in. And that is my equation. Once again, never have k in your final equation. You always should put the number you solved for in its place. All right, so let's take a look at this one. So again, z varies. So z equals directly with x. So x is up top. Inversely with the product yw. So inversely with that product. So that means both of them are down in the denominator. It's inverse to both of them. And now let's go and see what k is. I'm going to start plugging in all those values. So z is 6, x is 3, y is 4, and w is 1. So I'm going to multiply that 4 over. 6 times 4 gives me 24. Divide by 3. My k is going to be 8. So that means my equation, I should actually go and plug that 8 in. And so that is going to be my final equation. Okay, so again, as long as you know what we did yesterday, today is just a slight extension of that. It's combinations of those things we were working on yesterday. So let's escalate it a little bit here and talk about some word problems. The number of bags of grass seed N needed to reseed a yard varies directly with the area to be seeded and inversely with the weight of the bag. So that first sentence, it looks to me is giving me the structure of my inverse variation. Just like in every example, that first sentence always gave me the structure. So it's telling me N varies directly with the area, so that A goes on top, and inversely with the weight of the bag of seed. All right, so there I have my formula, okay? But I need to know what K is. I can't use it unless I know K. Well, that is what the rest of this is for. Okay, that piece right there. Find an equation that relates a variable. So if it takes two 3-pound bags to seed an area of 3,600 feet. So let's plug in what that's giving us. So the number of bags, it says it takes 2 bags for an area of 3,600 feet, and the weight of the bags is 3 pounds. So multiply the 3 over, so 6 equals K times 3,600. So 6 divided by 3,600. So our constant of variation is 1 over 600, or that is the decimal 0.01 or 0016. Repeating, for precision, I like the fraction, all right? So what that means is we have n equals 1 over 600 A over W. Okay, or since we're dividing in that, really an easier way I could write this would be just put that 600 down in the bottom like that. Okay, that would even be a cleaner way of writing this. Okay, they want to know how many bags will it take to seed 9,000 square feet? Well, let's plug it in. So the number of bags for an area of 9,000 square feet, well, the weight, we're assuming we're going to be using the same weight bag, okay, because that's the only bag I was talking about. So we're going to assume that we're still using that weight of 300, or of 3. So 9,000 divided by that 600 times 3. It's going to take 5 bags to seed that area. All right. What about our next one? Gravitational potential energy is a measure of energy. It varies directly, jointly, with an object's mass and height in meters above the ground. Physicists use G to represent the constant of variation. So here, we're going to use G instead of K. That's what that sentence is telling me. Okay? We're not going to use K, we're going to use a G to represent this constant of variation. So, the potential energy varies jointly with M and H. Now, for those of you that have taken physics, this equation should look very familiar to you. A lot of these examples that you're going to see throughout this section are actually from chemistry and physics. Chemistry and physics have a lot of variation equations in them. So, the skateboarder in the photo has a mass of 58 kilograms and potential energy of 2,273.6 joules. Use this to find an equation relating the variables. What is the gravitational potential energy of a 65 kilogram skateboarder on the half pipe shown? All right, so we're given the potential energy of that person. We're given the mass is 58. And in the photo, it shows a height of 4 meters. So we filled in everything, and now we want to find G. All right, well, that means we have to divide off the 54, or the 58, and divide off the 4. When we do that, we get the gravitational energy, or that constant of variation, is 9.8. Again, those of you who have taken physics, that number is actually very meaningful. You've seen it before. So it means gravitational potential energy is 9.8 times mass times height. And we want to know, well, what if there's a 65 kilogram skateboarder on the half pipe shown? What is their potential energy? Well, assuming they're at the same height, 9.8 times 65 times 4, they'd have 2,548 joules of potential energy. All right, so last skill I want to briefly go over is if I give you an equation, you should be able to describe the variation to me. All right, so this relationship goes both ways. I can give you the information and then you make the equation, or I can give you the equation and you tell me what type of variation it is. So how it works is you always look at what's over here. All right, so this is telling me Z varies. All right, that's always how you want to start it. So Z varies. Now, both of these are direct, okay? So you can say varies directly with both, or to be more precise, you could say varies jointly with X and Y. Okay, so that's really all it takes. Now this one, I apologize, there's actually a typo in. I'm going to put a Z down there. It shouldn't have the same variable twice. So I apologize for that typo. Can you fix that in your notes really quickly so we can begin our next example? So here this time, Y varies. Now X is up top with a K. So it's varying directly with X. And then the Z is on the bottom. So because it's on bottom, that's going to be inversely with Z. Okay? So everything you already know, you're just putting it into words for me. Now, here's a little caution for you. Okay? Notice, I never described K. Okay? Because K is the variation. So you don't describe K in it because you're just relating everything to whatever K is. So again, just make that mental note here that when I'm describing it, I never describe the K. I describe only the variables that are around it. Okay? So, once again, really good stuff today, and I hope that you're able to make those connections to yesterday. And in fact, that would be a great thing to put in your summary. How does today relate to yesterday? So take a moment here and can you please write out your summary for me and then come back to class ready to do your practice work.